Hello and welcome back to part 8 of my algorithms video tutorial series. In this one we're going to be covering bubble sort, which is probably one of the easier sorting algorithms to program. Hopefully you've already had a look at the CS field guide and you understand exactly how the algorithms kind of work. The sorting algorithms that you see here are the selection and insert. However, the bubble sort is one of the more interesting ones, and we covered it in class. If you look at, just do a quick Google search for a visualization of algorithms. This one is at csusfca.edu. You can do any one of them. The bottom line is that they all kind of show a visualization of how this works. I'm going to run this and then we're just quickly going to talk about what's happening. So with the bubble sort, all that's happening is that the two values next to each other are compared. If they happen to be smaller, like this one here, than the one that it's comparing with, it will swap them over. So what you see is that small values bubble to the bottom and bigger values bubble to the top. You need to go through this one n times n times. So if it happens to be the 100 items in here, you're going to have to go 100 times through. And each time you're doing a comparison, you've got 100 comparisons to make. So that ends up being an awful lot of comparisons, and this is considered to be one of the slowest and worst algorithms. This one you can see is slightly optimized because it's not comparing ones that have already been optimized, but we're going to keep it really simple, and we're going to try and do it with the simplest possible Python code that we can manage. So I'm going to just clear up my code from the last video. I'm not going to be using the binary search this time. What we are going to need from our utilities is this getRandomList function. We're going to need that to get ourselves an unsorted list that we're going to sort. And we remember that we can do this with any size. So it was a getRandomList is the thing that I wouldn't want to be able to use. So I'm going to use my getRandomList function here. getRandomList, and I'm going to pass in a size of 10, nice and manageable, just so that we can test this to make sure that it works. I'm also going to not need to print the result out just now, so what we should probably do is just print the data that we get so we can see what the list looks like before it's sorted. So I'm going to write the function in this piece of code right now, just so that we can have it in one place rather than jump between files. And we'll call this function bubble sort. We'll pass in a list of data. It's sometimes confusing. I'm going to call this my list down here, just because it does separate the fact that you can pass anything that you want. Any list can be sent to this. It doesn't really matter, and the function itself will be calling it data. The cool thing about passing lists to functions inside of Python is that it passes as reference. So I can actually, whatever data is, it's actually a reference to this list, so I can change it in place. And this my list will actually be the thing that gets changed, which is kind of cool, but it's weird if you don't understand that that's what's going on. So just like before, when we were looking at the example, I'm going to need this outer loop. So I'm going to just create this outer for I in range length of the data. So this outer loop, you may not have seen this this character before. This is a blank iterator. It's just a single underscore. It just means that I don't care what this is, so I don't need to use, like this could be for I in range, but I just don't need to use it, so I'm going to use an underscore. It could be C, it could be X, it could be Y. It doesn't really matter. It's just that I don't care because I don't need to use this, because I just need to know that I need to go through that many times the inner loop, which goes through however many times data, however many elements data has inside of it. The next thing is the actual inner loop itself. So I'm going to use I for this one, for I in range. And I'm going to go this time length of data, and I'm going to go -1, because I don't want to go right to the very end one, because I'm actually going to be checking one above the value that I'm going to be looking at. So I'm going to be looking at I, whatever I is, and then the one above that. So I don't want it to go out of range. And the simple thing that we want to do is if it's less, then we swap. So I'm just going to say that, sorry, if it's not if it's less, if it's actually greater, then we swap. So all we want to do is we want to check what the value, so if the value of the item at I in the list data is greater than the value of the one above it, so that's I plus 1, then we swap. And to swap it is this really weird thing in Python where we can actually do multiple assignment, it's called. So I can do two things on the left-hand side of the equal sign. So I can say that I want data I and data I plus 1 to be equal, and then you put two things on the other side of the assignment, and it'll just automatically put the first one on here and the second one after the comma on the one after the comma before the equal sign. So this is kind of like, it looks like it's cheating and it looks like it shouldn't work, but Python's weird that way and it does. So basically I'm saying that data I is equal to data I plus 1, and at the same time data I plus 1 is equal to data I, and weirdly enough in Python this kind of works. We should test this to make sure that it actually does. So let's write a little bit of test code. So I'm going to create this my list, which is a get random list of 10, and then I'm going to print my list, and then we're going to try using our new bubble sort. So we're just going to say bubble sort, and we'll pass in my list to it, and then afterwards we can print that my list and see what it looks like. So in theory, if I run this, we should see an unsorted list at the top, as we do, and then a sorted list at the bottom. Just for fun, what you could actually do is you could actually print out what the list looks like at this point in code, so that when you run the algorithm, you get the step-by-step sorting, and you can kind of see what's happened. So you'll see that obviously the 2 and the 7 starting up here, they're less than each other, so they don't change. But where we have a value like the 3 here that's less than the 6, you see on the when we get to it, they'll actually have been swapped over. So it's around about in here when they're actually being swapped, so that you can see that the thing changes as it goes. So the high values bubble up and the low values bubble down as the algorithm runs. And you obviously don't want to leave this in if you're going to be doing more than 10 items, because it could really lag out the computer. You probably want to test this with something much bigger, like say 100 or so, and then you'll see that you do end up getting your sorted list does actually work. However, we kind of don't really have a way of working out how efficient this is right now, and there's a couple of methods I'd kind of like to look at. The first one is we could simply return a value from this. We could create a count variable inside of the bubble sort, and then at the point in the inner loop here where we actually do something, where we do our comparison, what we can do is we can just make count go up by 1. And then at the very end of the algorithm, after both for loops have completed, we can just return count back from this. So what we can actually do when we run the bubble sort function is we can get the result back from it. We can get a value back from it. I'm going to store it in result. I'm going to print out my list, and I'm also going to print that I do an f string, so I can print it out nicely. Sorry, f before the strings, and then I say this took result comparisons. So this is a simple way to run this. So with a list of 100, we run this. It said this took 9,900 comparisons. If we compare, if we run the 10, you see that it took 90 comparisons. If we did say, so it was 1,000, so what about if we did 2,000? What you'll see if you make a graph of this, like we have done before, this is actually taking quite a long time on Replit because it's not that fast, but this took 3 million comparisons just to do 2,000 elements. So you can see that if you create a graph of this using your CSV writer code from the earlier videos, you should see a certain trend happen with these, with this bubble sort algorithm. Another method to test this is using time. So what we could do, imagine we could start a timer and end a timer so that we know exactly how long in time this takes. Now, using Replit may be not the best, most consistent way of doing it because you're relying on internet connection, you're relying on a server running somewhere in the world that runs your code. But if you're using Visual Studio Code, it's the same code, but you get a much more accurate result because it's running locally on your machine. But I'll show you how to do it anyway, should you be using Visual Studio Code. So we want to import time. The time has a certain function in it that allows us to capture the current time. And obviously, if we capture the current time before we run our bubble sort, and then we capture it afterwards, we can get the elapsed time from that. So let's just do that. So I'll capture time. So I'm just going to say that the start, so I'll call a variable called start, and we'll make it equal to time.time. And that, believe it or not, is a function. It returns a floating point value, which is the current time in like this milliseconds. Is a very, very small value because we're not doing really complex programs. By the time we get to the end of this result. So straight afterwards, I'm just going to say that the elapsed time is equal to the start time. Sorry, no, the current time. So again, I'll do time.time and I'll subtract the start time. So this will be pretty small value. If I print, will I print the sorted list? Yeah, I'll print the sorted list and I'll say this took result comparisons in, and we'll use elapsed seconds. And then this will be, as I mentioned, for like that much, it should be a fairly small value, like within a few seconds. So if I run this piece of code here and it printed out the original one and it was 3 million comparisons, nearly 4 million comparisons, and it took 5 seconds. So you can see, 5.19, whatever. You can see that that's one way, particularly with larger values, that you'll be able to get some time back from exactly how long it took to run on your computer, which is another way that you can do some analysis for the efficiency of this algorithm, as well as just the number of comparisons that it takes to run a specific algorithm. So we'll just add in our comment. So we want this docstring again, and then use bubble sort to sort data list in place and returns number of comparisons as an int. So this this value, now that we've written the comment, we can Control X this out and put it into our utilities. So I have a binary search that we did earlier. So let's go a couple of spaces and put in this bubble sort function. It's always good to make sure that it works inside there. So I want to make sure that I import it and just make sure that it still works. I did the wrong thing. So it's bubble sort. Get myself confused. So hopefully everything works as before. I might just drop this down to 100 just because I don't want it to take forever. And you can see that everything works as expected. And as I mentioned before, with a small number of comparisons, it's a pretty small number.